Leaving cert higher level 2015 paper 2 question 9. Joan is playing golf. She's 150 meters at this black point here from the center of a circular green of diameter 30, so we can put the radius on as 15. The diagram shows the range of directions in which Joan can hit the ball so she could land on the green. Find alpha, the measure of the angle of this range of directions, and give your answer in degrees correct to 1 decimal place. Well, if we create a right angle triangle here, so I've got my diagonal, which we don't know. I've got this side here along the bottom is 150. Same as if we drew the same radius going this direction, we'd have the 150 along that side, and this would be a right angle at the tangent. And then we have the radius of 15. And alpha is down the bottom here, the bottom of the 150 and opposite to 15. So the tan of A, well, I should probably, that's half A in there. We'll call it half A. So we'll just call it A for the sake of the question, and then we'll double it. The tan of A is equal to 15 over 150. That works out evenly to be 0.1. So the inverse tan of 0.1 is going to give me an angle size of 1 decimal place forward. We'll take 5.739, multiply it by 2. We're going to get 11 and 478. So that would 1 decimal place be 11.5 degrees. Part B of this question, at the next hole, Joan is at T and attempts to hit the ball in the direction of the hole at H. So she's way offline here. She's 190 meters going in the direction northeast. So her shot is off target and she lands at A, a distance of 190 meters. Excuse me. Let down my 1. From T, where ATH is 18, TH is 385. Find AH, the distance from the ball to the hole. So we're looking for X here. So you should be able to see when we have the two sides and the angle in between, we have to use the cosine rule, and we've no other pieces of information. You could try set up the sine rule and you could see that it wouldn't work. We don't have a second angle for a side opposite it. So we have to use the cosine rule here. A squared is equal to B squared plus C squared minus 2BC cos A, where A is the side on its own that we're looking for, and B and C are the two connecting sides to the angle A. So X squared is equal to 190 squared plus 385 squared minus 2 by 190 by 385 by the cos of 18 degrees. So we can straight away we can get X squared. Just type this into your calculator. We're going to get 45185. 0.4 I'm getting. The square root of this number will give me X. 212.56, 212.56. So to the nearest meter, X is a gigantic 213 meters from the hole. You could also use Pythagoras in this question. We drop a perpendicular down. We could get this side here. We'll call it Y. Using Pythagoras then we'd be able to get Z. Taking Z from 385, we'd be able to get, I'll call this side B. Now we have Y and B, and we can get X using Pythagoras all the way through the question and a little bit of subtraction. So either way would suit. On the next hole, where the ground is not level, Joan hits the ball from K up here. The ball lands at B down here. That's the path. And the height of the ball is given by the height of the ball above O. Above the horizontal is this line here. That's given by this formula. H is equal to minus 6t squared plus 22 plus 8, where t is the time in seconds after the ball is struck and h is the height of the ball. Find the height h above k. So this h here, or above O, OB. So this is an easy one when obviously before she hits the ball, time is equal to 0. So h would be equal to 8 meters. 0, 0. Just leaves me with my constant at the end. Simple intro into this part. Part 2 of the question. The horizontal speed of the ball over the straight distance OB is a constant 38 meters per second. For the angle of elevation of AK from B. So we're looking for this angle in here. If you weren't sure which one they meant, get that one and write the answer to this one down too, using three angles and a triangle out up to 180. Correct to the nearest degree. So we'll call this the angle A. So what have we got so far? We have h is equal to 8. So we're definitely going to need another piece of information on the triangle, and it has to come from this constant speed of 38 meters per second. So what we could do is we could find the time along here, the time taken to get from O to B. We'll be able to use this equation to solve for time, because the time at B here, or the height at B here, height will be equal to 0. So let's let height equal 0. So minus 6t squared plus 22t plus 8 is equal to 0. So 6t squared, if you don't want to use the minus part, minus 22t minus 8 equals 0. So we'll try 6t by t first. If it doesn't work, it has to be 3t by 2t. I can see it's going to be a 4 and a 2 here to get to 24 and back to 22. So minus plus. So t is equal to minus 2 over 6. T can't be a negative time in this case. Or t is equal to 4. So this is the time here. Time is equal to 4 along here. So it's traveling at a constant 38 meters per second. So it's traveling at 38 for 4 seconds, which is 120 and 32, 152 meters. So now we have this side here, 152. So we have the two straight sides, so we can use tan here to get my angle. 152, 8, A. The tan of A is O over A, so 8 over 152, so it's a small angle. So A, the inverse tan of 8 over 152, you don't have to write it down, you can just write the angle. 3, correct to the nearest degree, 3.01 degrees. So A is equal to 3 degrees. And say we're unsure in the question, write angle B here. Therefore angle B is equal to 187. Not 187. Angle B is equal to 90 minus 3, 87. Next part of this question. Part D of this question. At a later hole, Jones' first shot lands at the point G on ground that's sloping downwards. So our ball is here. A vertical tree CE. So this big guy here, there's a tree diagram in the exam, big tree going beside this, but we're just dealing with trig here, so create your triangle. And the elevation, or we're told the tree is 25 meters above the ground. So this one has to be 25 minus h. You can see that straight away, and that is one of the questions here. To write CD in terms of h, and D is this point here, so it has to be 25 minus h if the total is 25 and the top bit is h. So we have that one done already, and write D in terms of h. Okay, well this information here is telling me that the tan of theta is 1 over 2. In the current case of the triangle, the opposite over the adjacent is equal to h over d. So d is equal to 2h. And that's actually all they're looking for here in part 1. A really easy question in 2015. Last part to this question, hence or otherwise find h. So what we have in this bottom triangle here, let's have a look at this bottom triangle. Just multiple ways to do this, but in this bottom triangle we have a right angle. We have 25 minus h. We have d up the top here, which we were told, we worked out to be 2h, and we have this 25. So that would be the first way to approach this question, just using Pythagoras. 2h to be squared plus 25 minus h to be squared is equal to 25 squared. Those 25 squares are going to cancel. So we're going to get 4h to be squared plus 25 25s are 625 minus 25h twice plus h squared equals 625. So I'm left with h squared, 5h squared minus 50h is equal to 0. Divide by 5 to get h squared minus 10h equals 0. So it's very simple factorization, h by h minus 10. So h can't be 0 because it's a distance. H is equal to 10, and we're dealing in meters in this question.